Hi everyone, I'm Josh Blumenstock from UC Berkeley, and today I'm going to talk about how new sources of data as well as machine learning are creating solutions for responding to the COVID crisis in developing countries. Um, to provide a little bit of context, I want to begin by highlighting the scale of the humanitarian crisis facing low and middle income countries. So as you can see in this New York Times headline, and this is according to the World Food Program, by the end of the year, over 250 million individuals are expected to be suffering from acute hunger. And what's going on is that in addition to the public health threat of the virus itself, when governments are imposing lockdown orders, basically stopping people from working, that removes the primary income source for hundreds of millions of households who are already living below the poverty line or just above it. And when you take away the primary means of subsistence from a household that's already vulnerable, that creates the scope for massive food insecurity. So to make this a little bit more concrete and to provide some context for what comes, let me briefly highlight the situation on the ground in one country that I'll talk a little bit more about, which is Togo. So at the beginning of June, from June 2nd to 14th, I and my team, in partnership with the government of Togo, conducted a phone survey where we spoke to 15,000 different individuals. And in that survey, we asked them what their typical weekly income was in February 2020, before the coronavirus crisis. And then we asked them what their income was in the past week. And what you can see here is that both for men and for women, there was a huge drop, about 70% in weekly income. And so how does this translate to food insecurity? Well, what this figure is showing you is how respondents answered the question about skipping meals. So we specifically asked them, in the past week, on how many days did you or someone in your household have to reduce the number of meals eaten in a day? And as you can see, of those interviewed, more than half reported that they were skipping multiple meals each week. And 1 in 5 reported that they had to skip meals every single day. So in response to this humanitarian crisis, governments all over the world are mobilizing relief efforts. Estimates are that around 200 different interventions have been planned or introduced in response to COVID-19 in developing countries. Unfortunately, in most cases, particularly in low and middle income countries, the governments don't have enough money to help everyone. There isn't the funding to provide a universal basic income or to provide some sort of subsidy to all individuals and households in the country. And so this opens the key question behind this talk, which is how do humanitarian efforts quickly and accurately find those with the greatest need for humanitarian support? And the reason this is a challenge is because that many developing country governments don't have good data on who amongst their population needs the aid most urgently. Existing registries are often out of date since many people work informally. People aren't typically paying taxes on all of their income, if any of it. And of course, the government doesn't have any way of collecting this sort of information in the middle of a pandemic. So what I'm going to focus on in this talk is how new data sources, non-traditional data, in particular from satellites and mobile phone networks, are creating options for solving this targeting question of getting resources or identifying individuals most in need of resources. I'll contrast the status quo, which is using existing government registers or existing survey data, to 3 non-traditional approaches that rely, as I mentioned, on satellite data on the one hand, and then mobile phone data, and potentially the combination of both of these data sources. So let me start by talking a little bit about satellite-based targeting. So the idea behind satellite-based targeting is that high-resolution satellite imagery, which is now publicly available for multiple companies, including Google Maps and Planet Labs and Digital Globe, can reveal a lot about what on-the-ground conditions are like. And as you can see from the 4 pictures in this slide that were chosen randomly from different locations in Nigeria, it's pretty evident that some regions are wealthier than others. The wealth of a region can be inferred from information like the roofing material, the road quality, the size of a farm plot, the density of buildings, and so forth. And at its core, machine learning is a technology for pattern recognition. And so what this approach that I'll talk about more in a second is doing is to use machine learning to detect these patterns of wealth and poverty and then use them to construct incredibly high resolution poverty maps. So how does it work in more detail? What I'm going to talk about is a standard recipe that was really first developed by Neil Jean and co-authors in a 2016 paper in Science. But there's been a series of refinements since then, including the reference on the bottom of the screen. But the basic idea is to start with some notion of ground truth, where ground truth typically comes from a traditional face-to-face household survey. So I'm showing you a map of Nigeria that shows the locations of all of the households that were surveyed. And in each survey, there are a bunch of questions that relate to the wealth of the household being surveyed. Questions like, do you own a motorcycle, a bicycle, a telephone, does the household have electricity, and so forth, which can be converted into something that a wealth index, which is really just the first principal component of all of the asset questions, that is, we think of as like a target variable. And then using the geographic information, we match that to information from, say, satellite imagery. And there are a lot of different ways to think about doing this, but the key point is from the satellite imagery, we extract features. And features can be things like what is the roofing material, or we can use deep learning methods, which is what we do, to extract a little bit less interpretable features from the actual image. But the point is, for each of these survey locations, we'll call those are the locations indexed by I, we have some notion of ground truth, which is YI, and we have some features that are coming from the non-traditional data, XI. And then we use supervised learning methods to map the X's to the Y's. And so the key point here is that when we're done with this process, we start from ground truth that looks like this. And instead of doing what traditional national statistical offices do and construct geographic aggregates at the ward or state or region level, we can use the high resolution satellite imagery to construct much higher resolution, more granular maps that provide estimates of the geographic distribution of poverty. And why is this relevant for targeting humanitarian aid? The idea is, instead of thinking, oh, well, we'll target this state and maybe this state, you can go sub-state, sub-regional, and say, oh, let's just think about targeting the poorest neighborhoods, the poorest villages. So let me give you a quick demo of what this actually looks like. We've done this globally using high-resolution satellite imagery from around the world. And what we've done is produce 2.4 kilometer grid cell estimates of the distribution of wealth for everywhere on the planet. And what we're working with the Nigerian government right now is to show how they can use these maps to identify, pockets of poverty, pockets of areas of need, potentially within larger areas where the region may not be poor on average, but there might be very poor villages or neighborhoods, again, that should be prioritized for support. And when you show this sort of estimates derived from satellite imagery to policymakers working in these countries, it truly is just a different perspective on what the spatial distribution of poverty looks like in their country. So a natural question to ask is, are these estimates accurate? And what we've done is we can compare these estimates, again, produced from satellite imagery, using data from a bunch of different countries, to a new independent source of ground truth, in this case from Nigeria. And we see very strong correlations in the estimated wealth of regions from our satellite-based deep learning methods, as well as from standard national statistical methods of extrapolating and averaging over administrative regions. And this is true at the state level. This is true down at the local government authority, the LGA level. And then for the satellite tiles, these 2.4 kilometer grid cells where we have labels in the survey data, we can say, well, how accurately do the estimates from the satellite method compare there? And we still see a very strong correlation around 0.78. And it's worth noting that the correlation between the satellite-based methods and traditional methods are much greater than other baselines that one might imagine. For instance, taking the state average or taking the LGA. If you're trying to estimate the wealth of one of these households where we know the true wealth, it's much better to use the high-resolution satellite map than it is to use, say, the LGA average or the state-level average, which is the status quo. So now I've talked a bit about the satellite approach. Let me pivot to talking about how phone data, data from mobile phone companies, can also be useful in targeting humanitarian aid. So the key point here is that you've seen how satellite data can be used to potentially identify regions that we might want to prioritize for support. The question then is, how do you identify the individuals in those regions? And this is a non-trivial problem because, as I mentioned at the beginning, many governments don't have up-to-date population registries that tell them who lives where. Now, of course, you could imagine sending out a small or potentially large army of data collectors to go door to door to basically take down information for who lives in which neighborhoods. But in many cases, that's impractical, in particular in the midst of a public health crisis where you're trying to minimize face-to-face contact. So one option that we've been testing and several countries are exploring is to use location information collected by the mobile phone companies to identify people who live in those regions. So an example of this is happening in Uganda right now, where the idea is that using high-resolution poverty maps or some other method, the government identifies priority regions for assistance. Then the phone company, using data on which towers people are pinging off of on their mobile phones, identifies people whose home location is within that priority region. Then the phone company does some outreach by sending an SMS or a USSD message to the subscriber to ask if they're interested in participating and learning more, and then the people who qualify receive a direct payment to their mobile phone account, their mobile money account. And it's worth pointing out that why are we involving the phone company? Well, if there's a better way that the government has to identify eligible people and provide them transfers, then there's no need to involve phone data or the phone company. But often, it's the phone company's databases that are the most comprehensive and up-to-date. And so this provides a way of getting transfers, identifying people who live in a region and getting them cash. Okay, so that gives you a sense of how the location information collected by mobile phone companies might be useful for this question of targeting aid to the people who need it most. Now I want to talk about how richer data collected by the phone companies can provide for even more nuanced targeting. And the idea here is that even within a region, by analyzing patterns of mobile phone activity, it's possible to separate potentially eligible from ineligible beneficiaries. Again, based on how they're using their phone and aided by different methods for machine learning. So to give one concrete example of how this can work, let me highlight the case of NASCO in Nigeria. So this is a small pilot program where, again, the government starts by identifying specific regions that they want to prioritize for assistance. And then, and this is the key difference, working with the mobile phone company, the MNO, they identify individuals in that region whose airtime balance on their mobile phone is below some critical threshold, based on the key assumption that people who don't carry a lot of money in their phones are more likely to need government assistance than people who have a lot of money on their phones. Now, I'll come back to that assumption in a second, but once they've made this identification, then they transfer money to the people that have low airtime balances. So stepping back for a second, what do we think about the pros and cons? So the big advantage of this is it allows for differentiation within a region of potentially wealthy and poor, or the neediest from the less needy individuals. Now, there are some huge and obvious disadvantages, one being that we have no sense a priori whether this airtime balance threshold is a good proxy for the actual need of the individual. There are also concerns about data privacy, sharing data between the phone company and the government, and how to think about individuals without phones. Let me pause and talk about this last point for a second, because it is important and it will affect everything that follows in this talk, which is that mobile phones are very widespread in developing countries, but they're not yet ubiquitous. And so what I'm showing you here is data from Togo again, where I'm showing you the mobile phone penetration for each prefecture in Togo. And you can see very high penetration in the greater Lomé capital region, as well as some of the wealthier, more urban areas around Chaozhou. But in some of the other regions, you get closer to like 50% mobile phone penetration. And these figures here are showing you the penetration at the individual level by age and gender, and then again at the household level by age. And so what this really highlights is, despite all of the fancy technology and machine learning I'm talking about, it really highlights the need to integrate these approaches with existing social protections that are often run by local institutions, community-based organizations, as well as to build in careful processes for people to manually register who don't have phones, and to appeal if it's a poor person whose airtime balance is very high for whatever reason, they should still be able to get in, even if they're not sort of initially targeted with the first pass. But now let me talk about a little bit, a slightly more nuanced version of this. And this is something, a paper that we just published using data from Afghanistan. And so here, working with the World Bank that had run this ultra-poor graduation program in Afghanistan, where the idea is it was a big push intervention where they first worked to identify ultra-poor households and then gave them a huge amount of resources. They gave them money, they also gave them livestock, training, and so forth. And so how did this program work? And this is fairly characteristic of one of these very heavy touch interventions, is they had this multi-stage process to identify eligible beneficiaries, where they first went into the community, they had the village elders sit down and basically rank households in the community to determine the poorest decile or something like that. And then they sent surveyors to those poorest households to collect data. And based on the combination of these community-based wealth rankings and the in-person verification, they identified the ultra-poor. Now, the big issue here is that this is a very costly, in terms of resources and time, effort to identify the ultra-poor, and certainly not the sort of thing that one could mobilize in the context of a humanitarian global health pandemic. And so the question we sought to answer in this paper is whether ultra-poor status could be inferred directly from mobile phone data. And so how did we do this? Well, we went back to those individuals who were surveyed through the World Bank program. We collected informed consent to match their survey data, which I'm showing a cartoon of down here, with data that we obtained from the mobile phone operator. And then we asked the same question as before, but using machine learning to build the answer. In other words, can machine learning methods identify who are ultra poor based on how they use their phone data and separate them from the non-poor? And so we can think about, why might this work? Well, intuitively, different types of people use their phone differently, right? Maybe poor people have lower airtime balances on their phone than wealthy people. Maybe they make a different number of calls a day. Again, I don't want to make those assumptions, because in practice what we do is we use supervised machine learning algorithms to find these patterns, right? We have this labeled data set where for some individuals we know what their actual socioeconomic status is because we had a survey with them, and we match that to their phone data. And so we say, okay, what are the characteristic patterns of ultra poverty in phone data that we can infer from this labeled training set? And what you can see is that indeed, people who this multi-stage, time-intensive effort identify as ultra-poor, they use their phones differently from the people who are not classified as ultra-poor. One very simple difference is that the non-ultra-poor, which are the blue distributions in these histograms, use their phones on more distinct days over the course of a year than the ultra-poor, which is this orange. And from the phone data, you can infer hundreds, if not thousands, of different characteristics of phone use. And for many of these different characteristics, you see differences between the ultra-poor households and the non-ultra-poor households. And so when we put all of these data into the machine learning algorithm, there's a couple key points. First is that, and this is the ROC curve, the CDR, or the phone data method, is comparably accurate to the current status quo methods, which rely on consumption information collected through a survey or asset information collected through a survey. And this is important because collecting consumption and asset information is very difficult and very costly and time intensive. But another important result in this paper is that when you combine all of these methods, if you assume that you have access to all of these, not just one of them, then you can do better than any one particular data source used in isolation. So what I've shown you so far is that phone data can accurately predict wealth and poverty. And in papers you can find on my website, we've repeated similar analyses in several different countries, and we find that in general, mobile phone data can explain about 40 to 50% of the variation in wealth as measured in surveys. And so the question then is, can this possibly help improve targeting of humanitarian relief in response to COVID? And the answer is that practically, the answer is almost certainly yes, right? At least to the extent that these new data sources can be used to provide a second social safety net for people that would otherwise be excluded from the existing benefits program. This is a way that can likely catch people that would otherwise not be caught. But a second and equally important question, in addition to can this work, is do we want this to work? And in particular, do the benefits of using these methods outweigh the costs? And of course, we want to be able to enable effective humanitarian response. But at the same time, we also care about sort of key social, legal, privacy issues about like what data is required to make these methods work. Do we want to concentrate power amongst the technocracy, and particularly in weaker or previously authoritarian states, these might be very important concerns. And so, you know, this isn't the focus of the talk, but it's worth pointing out that human rights doctrine typically emphasizes the need for any sort of infringement on privacy or something like that in the context of an emergency to be necessary and proportionate. And so key points to have in mind, again, the answer to this question, these two questions, is it going to work and is it worth it, are going to be incredibly context specific, right? It's impossible to say in general a country should use these data or they shouldn't use this approach. It's going to come down to thinking about, you know, what are the existing legal frameworks that are in place, exactly what data is required. Maybe the phone location data isn't as sensitive as the airtime balance data, but certainly all of the full mobile phone metadata is going to be much more sensitive than both of those. Is there an opportunity to get informed consent to use the data? That's something that, for instance, the approach in Uganda with Give Directly, they explicitly asked for consent to use the recipient's mobile phone data in order to determine their eligibility. That's obviously much more attractive than something where no consent is possible. And then, of course, you know, under this bullet of restricting access, who is it that's going to have access to the data? In many cases, you might not want the government to have access to all of these data. There may be a third party that you trust, there may not. And if there isn't, then maybe you have to think about different approaches. So with those concerns and considerations in mind, let me show you some simulations that we've run that make a little bit more clear the differences between these different approaches to targeting. So we've been working very closely with the government of Togo for several months now on their response to coronavirus. And so already they've provided cash transfers to about 10%, about 550,000 households in the country. 550,000 individuals in the country. And right now they're interested in expanding that program to provide 50,000 more beneficiaries with cash transfers. And they're asking the question, who should we target? And what this slide is showing is simulations we've run that contrast on the left how those 50,000 households would be chosen if targeting were done using existing and the most recent government survey data, which provides representative estimates of the average wealth of the prefecture. And so here we're showing at the smallest administrative unit, if we then targeted the poorest cantons, how that 50,000 budget of households would be used. And then on the right, I'm showing how that would compare if we targeted using satellite data here and then mobile phone data on the right, on the far right. And so what you can see is that these new data sources are providing much greater granularity than traditional data. And that really is the central advantage of this approach, is it allows for disaggregation below the geographic unit that traditional survey data allow for. And when we run the simulations, we see that relying on phone and satellite data can both increase coverage and reduce leakage. And so coverage is what percentage of the true poor get covered, and on the right is what percentage of the non-poor who don't get benefits accidentally do get benefits. And so both for the poor and then on the right I'm showing extreme poor, you see that the CDR-based targeting is doing better. So let me briefly summarize the point of this talk. The first is that new data sources, and in particular satellite data and mobile phone data, are creating options for more effective targeting of humanitarian aid. I think the key use case is that these data, again, which are often more comprehensive than existing government registries, can provide a second social safety net to provide benefits to people that might otherwise slip through the cracks. And importantly, this is meant to work in tandem with existing social protections, not as a replacement. But as I've highlighted, there are many key practical, social, and ethical considerations about how that integration with existing protection programs works, how to think about data access and privacy, people who don't have phones, manual appeals and verification, and many other concerns that are really going to depend on the actual local context. And I'll close by making this point that I'm focusing on the targeting technology, but of course this is just one small link in a much longer chain that's required to effectively get cash payments from essential government coffers to individuals and households on the ground. And I'll leave this up here. It has my contact information on the left, as well as a recent Zoom call with the team that's been working on this research on the right. And yeah, thanks a lot for your attention so far, and I look forward to handling any questions during the Q&A.